So in class, we learned how to sketch curves by using the first and second derivative tests to find relative minimums and maximums, and by finding intervals of increasing or decreasing and their concavity. To make it more simple, a curve can be thought of as a roller coaster. Imagine that the position of the coaster is given by an equation, f of x. In most curve sketching problems, you will be asked to make a rough sketch of f, or the coaster itself, when given other information about the roller coaster. This information can include the derivative of f of x, or f prime of x, which will give you the slope of the roller coaster at any given point on the track. It'll tell you exactly how steep the track is, a positive slope meaning that the coaster is going up, and a negative slope meaning that it is going down. If you think about it, this can also be used to define the intervals of increasing and decreasing. If the coaster is going up at a specific point, it is reasonable to think that the position is increasing, and if it's going down, then that means that the position is decreasing. When the slope is 0, the coaster has leveled out. Using test points, the first derivative of the coaster's equation can tell you exactly where the ride is going up, going down, or leveling off. It can also tell you where the track goes over peaks or into valleys, so to speak. When the slope of the track changes from positive to negative, so when the coaster changes from going up to going down, the graph of the coaster has a relative maximum. The same works for relative minimums, where the coaster changes from going down to going up. Obviously, to change from positive to negative, or vice versa, the slope at some point will have to be equal to 0. So every time that there is a point that makes f prime of x equal to 0, known as a critical number, you know that there is either a peak or a valley on the coaster. To figure out which one it is, all you have to do is pick test points on either side of the critical number and use the valley and peak method. You will also probably need to find the intervals of concavity of the coaster, which will tell you whether any point on the track is part of a peak or a valley. If you take the derivative of the slope, you will end up with an equation or graph that will give you the concavity at any given point, otherwise known as f double prime of x. Using test points from anywhere along the track, you can determine whether that section of the coaster is concave up, like the valleys, or concave down, like the peaks. If the test point results in a positive number, then the coaster is concave up, meaning that the section of the track is part of the valley. Likewise, if a test point results in a negative number, then you know that the coaster is concave down and part of a peak. It's also important to find the points at which the concavity of the track changes, which are the points that make f double prime of x equal to 0. Using this method and the other method with the first derivative, you will be able to accurately find exactly what sections of the track are increasing or decreasing, and whether they are concave up or concave down. When doing curve sketching problems, it's usually really useful to write down every interval that you have found, along with whether it's increasing or decreasing and its slope. This will allow you to make a rough sketch of the roller coaster because you now know the shape of the track. In order to find the exact position of the coaster on an xy coordinate plane, usually you would put critical numbers from the first and second derivatives back into the original equation of the coaster, but that's only if that's given. This will give you the exact points for the changes in slope and the concavity, though most of the time all a problem will ask of you is for a rough sketch, not an exact one. So now that you know the basics of curve sketching, let's try a practice problem. With most curve sketching problems, it'll start out by giving you a graph of f prime, like the one shown above. From there, the first thing that you'll want to look at is the places where the graph of f prime crosses the x-axis, or where f prime is equal to 0. On this graph, that's at x equals 0, x equals 4, and x equals 10. The next thing you want to do is place these three numbers on a number line labeled f prime. This is when you can use those test points on either side of the critical numbers to find out the intervals of increasing and decreasing. For the purposes of this problem, let's just assume that the coaster starts at negative infinity and ends at positive infinity. So from the graph, we can see that f is increasing on the intervals 0 to 4, and on the interval 10 to infinity, and f is decreasing on the intervals negative infinity to 0 and 4 to 10. Going back to our number line, we can see that at x equals 0 and x equals 10, the slope is changing from negative to positive, which means that there's a relative minimum. Likewise, because the slope is changing from positive to negative at x equals 4, then that means that there's a relative maximum. Now that we know all that, we can move on to the second derivative. Again, the first thing that you want to look at here is where the slope of f prime equals 0, or where the graph of f prime levels out. On this graph, that's at x equals 2 and x equals 8. You can now put these numbers on a separate number line and use test points to find the intervals of concavity. We can see that from negative infinity to 2, the slope is positive. From 2 to 8, the slope is negative, and then from 8 to positive infinity, it's positive again. This means that the graph of f is concave up on the interval negative infinity to 2 and the interval 8 to positive infinity, and then concave down on the interval 2 to 8. Now is the time when it's really useful to write down every possible interval, along with whether it's increasing or decreasing and its concavity. This just helps you stay more organized when you go to sketch the final graph of f. Now we know that on the interval negative infinity to 0, the graph of f is decreasing and concave up. We know that on the interval 0 to 2, the graph is increasing and concave up. On the interval 2 to 4, the graph is increasing and concave down. On the interval 4 to 8, the graph is decreasing and concave down. On the interval 8 to 10, the graph is decreasing and concave up. And finally, on the graph of 10 to positive infinity, the graph is increasing and concave up. Now it's time to draw that coaster. A useful pro tip is to take all of the critical numbers from the first and second derivatives and make sure to mark them on the graph, just so you remember where they are. Then we can go back and, using all of the information that we found out about the intervals, start to sketch the graph. So first we start out with decreasing concave up, then increasing concave up, increasing concave down, decreasing concave down, decreasing concave up, and finally, increasing concave up. And there you have it. You've just built your very own roller coaster.